Hi everyone. In this video I will be demonstrating how to test for first stage moderated mediation using Stata. And unfortunately Stata does not have a ready-made ability to perform this type of analysis, and so in order to do this ordinarily you would have to use some programming. But what I've done is I've worked up a do file that with some fairly minor modifications on your part should allow you to test these types of models. And moreover, I've created the do file to generate results that are comparable to Andrew Hayes' process macro when you're using process model number 7. So before I actually get started with the demonstration, I do want to review what a first stage moderated mediation model looks like. And so we'll begin just by considering a standard simple mediation model. So with simple mediation we have variable x, which is our independent variable, variable m, which is our proposed mediator, and variable y, which is our dependent variable. And so you'll notice in this mediation triangle that we have 3 single-headed arrows, each of those reflecting a direct effect of one variable on another. So path A, path B, and path C prime right here, the coefficients for these paths are estimated using either SEM or least squares regression. I've actually developed the do file to create estimates using least squares regression, which is what Hayes' process macro uses. So at any rate, you'll see that path A is estimated through a regression of the proposed mediator onto X. So that's our path A. And then paths B and C prime are estimated through least squares regression, regressing Y onto M and X right here. So when it comes to testing for mediation, what we want to do is to quantify that mediation first. So the indirect effect of X on Y through the mediator, M, is computed as a product of A and B, or paths A and B. And so typically what's utilized is bootstrapping in order to create a confidence interval, a percentile confidence interval, to test whether the indirect effect is significantly different from 0. Now when it comes to first stage moderated mediation, you'll notice that we still have our x, m, and y variables, but we've also added variable w right here. And you'll notice that we have a path drawn from w to the path from x to m. And what that's signaling from a conceptual standpoint is that the effect of x on m varies across levels of w. In other words, w is the proposed moderator of the effect of x on m. And you'll notice that we don't have a single coefficient a anymore. Rather, a is represented by these values right here, where we have a1 plus a3 times w. And that is computed from an initial regression model where we're regressing our mediator onto x, w, and the product of our focal independent variable x and our proposed moderator w. So you'll see that we have path A1 right here, we have A2 and A3 right here. So that's where the A1 and A3 are coming from in this expression. You'll notice too that we have our second regression, and it's pretty much consistent with our previous mediation model. You'll see that we have y regressed onto m and x, and we have path B and path C prime estimated right here. So the basic idea with moderated mediation is that our interest is looking at the effect of x on y through the mediator, but by virtue of w moderating either our path A or path B, then it's possible then that w would be moderating the indirect effect of x on y. So the reason why this is called first stage moderated mediation is because w is moderating this first path right here. If we had second stage moderated mediation, then w would be moderating the B path instead of the A path. And then it's also possible to have both first and second stage moderated mediation, but obviously we're not going to be working with that in this presentation. So now let's consider a couple of effects that we will be computing and testing when we run our analysis using Stata. So first off, let's talk about the conditional indirect effect. And as I said before, if this was a standard mediation model, we would have path A and path B, and the indirect effect would be the product of A and B. Now, because path A varies across levels of W right here, then we can compute what's called conditional indirect effects. So in other words, we can take the A1 plus A3 times W and multiply it by B, and so we end up with this expression right here. And so what that means is, and when we're talking about a conditional indirect effect, we're talking about the indirect effect of X on Y at different values on W. Now, when it comes to actually testing whether we have moderated mediation, we're going to be relying on the index of moderated mediation, and that's computed as a product of A3 and B. So what we'll be doing when we run our analysis using Stata is we'll be generating bootstrap confidence intervals and then testing whether these effects are different from zero. But the main effect when it comes to testing for moderated mediation, the main index that we're going to rely on is this one right here. So even though if we have conditional indirect effects that are significant or non-significant, that's irrelevant to the question of whether we have moderated mediation. It's really just going to be a question of whether this index of moderated mediation is significant. And then if it is, oftentimes then we follow up by examining those conditional indirect effects. So for our demonstration, this is the model that we're going to be testing. So our conceptual model up here, you'll notice that I've got interest serving as my independent variable, my focal independent variable, engagement serving as the proposed mediator, and then achievement serving as the dependent variable. You'll see that we have self-efficacy serving as a proposed moderator of the effect of interest on engagement. And then I've also added in socioeconomic status as a covariate in our model. So the two regression models that we will be working with look like these below right here. You've got engagement regressed onto interest, efficacy, the product of interest and efficacy, and then also socioeconomic status. For model 2 right here, we've got achievement regressed onto interest, engagement, and SES. Okay, so now I've opened up Stata and the data is already in there for us to run our analysis. And before I actually get started with this demonstration, I do want to mention that underneath the video description you will find a link to the data file that I'll be working from in this presentation, so you can download a copy of the data to follow along. Additionally, you will find a link to the do file that I'm going to be working from, so you can download that, and I'll walk you through how to use that do file in order to carry out your analysis. So at any rate, in terms of the variables in our data set, we've got interest, efficacy, SES, engagement right here, and there's achievement right here. So let's go ahead and open up our do file. So I'm going to click on the do file editor icon, and I'm going to go to File and Open, and I actually have a copy of this under my Downloads folder. So I'm going to open that up, and this is what I've written. It was a lot of fun to write for sure. And at any rate, when it comes to making changes, there's only one section that you need to make any kind of changes to or any modifications to. So I'm going to walk you through how to use this and then generate our output. So you'll notice that as you kind of scroll down, there's a little section right down here. It says make changes to this section only. So I would encourage you to avoid making any changes in any other sections of this do file. But basically what you're going to be doing is specifying your independent variable, mediator, Y variable, and W variable or moderator variables. You're going to specify any covariates that are going to be included in the model. You can indicate whether you want to use mean centering or not use mean centering. You can also indicate what kinds of conditioning values that you want, as well as number of bootstrap replications, seed value, and then you can request a plot if you want. So what I'm going to really quickly do is walk you through how this goes. So first off, you'll notice that I've got right here, this is basically setting up a global macro, and essentially it's going to contain the variables that we're going to be using in our analysis, or the main variables. So inside the quotation marks right here, this is where you would put your variables, and so I'm just going to get rid of that and kind of walk you through how to enter this. So you'll notice that in terms of the instructions, it says below, enter the focal independent variable x, then the mediator, then the dependent variable y, and then the proposed moderator in that order. So that's going to be really important that you enter it in that order. So for this, we're going to type inside the quotation marks, I'm going to type interest, that's my independent variable, then we're going to type in engage, which is the mediator, then our achieve variable, which is the dependent variable, and then efficacy, which is our proposed moderator. When you scroll down a little bit further, we're also setting up another global macro that would contain a list of the covariates that you're going to include. So if you don't want any covariates in the model, you can just leave that blank. So just leave the quotation marks with nothing in between. But I'm going to go ahead and add in SES because that's the model that we were talking about. When you scroll down a little bit further, you'll see that I'm setting up another global macro, which is creating an option allowing you to either center or to not mean center your x and w variables. So if you set this at 0, then you are basically asking the program not to do any mean centering. If you set it at 1, then you're asking it to perform the mean centering prior to forming the product term. So I'll go ahead and just leave this set at 0 for the time being. We'll scroll down, and then we have global, basically conditioning values. So if that path from our independent variable interest to engagement, if that path looks like it's being moderated, then one of the things that we would want to do perhaps is to test simple slopes, basically test the effect of interest on engagement at different values of our proposed moderator, which is self-efficacy. So if we set our conditioning values option to 1, then that's going to use the standard pick-a-point approach of 1 standard deviation below the mean, at the mean, and 1 standard deviation above the mean on the proposed moderator. If we set our value at 0, then we would be using the 16th, 50th, and 84th percentiles with respect to our x and w variables. So I'm going to go ahead and just stick with the conventional approach right now, setting this equal to 1. So we're going to be using, again, 1 standard deviation below the mean, and 1 standard deviation above the mean on our x and w variables. We'll scroll down a little bit further, and you'll notice that it says global boot reps, and I've set this by default equal to 1,000. So you can change this number. Don't include any commas or anything like that. Just set it at 1,000 or 2,000, but no commas or anything of that nature. And this is going to be important for generating our percentile bootstrap confidence intervals. So basically we're going to be using bootstrapping, so this is the number of bootstrap replications that we are requesting. So again, I've set this at 1,000. You can certainly set it higher or lower if you want to do that. When we scroll down a little bit further, you'll see I've got global seed value. And so basically, if you set this to 0, then the program is just going to use a random number generator to provide a seed value when performing the bootstrapping. If you set a value of your own, then what this will do is it will allow you to generate those bootstrap confidence intervals that are the same. If you were going to replicate your results in the future, you can use that number. So I'm going to leave this set at 0. And then down at the bottom, we've got global plot, and I've set that equal to 1, which is to say that I would like to request a plot of the simple slopes. If I set that at 0, then it's not going to generate that. So at any rate, you'll see we'll just kind of stick with these options right here. So we're set up to execute our do file. So I'll click on the button for execute do, and you'll see really right now we have our plot that's generated, and you'll see in the background we have the bootstrapping taking place right here. So now we have our results that are given, and I'll kind of scroll up and we'll walk through each of of our outputs. So you'll see first off we have our first regression model where we are regressing engagement onto interest, our focal independent variable, efficacy, our proposed moderator, the product of interest and efficacy, and then also our covariate SES. So when it comes to interpretation of the results, the coefficients for interest and efficacy, basically those are interpreted as the effect of either interest or efficacy on engagement for a case falling at 0 on the other variable. And that's actually one of the reasons why we oftentimes will request mean centering of our x and w variables, so that it gives a value of 0 a meaningful point. So in other words, right now, because we did not request mean centering, we would just basically say that the effect of interest on engagement is negative 0.0924 for a person falling at 0 on efficacy. But if 0 does not fall within the range of values or the observed values for efficacy, then that kind of renders that coefficient meaningless. And the same would go in reverse with respect to the efficacy variable. So again, that's one of the main reasons why we oftentimes will request mean centering prior to the formation of our product terms. So when it comes to the regression coefficient for the product of interest and efficacy, we have it right here, and you'll notice that we have statistical significance for that interaction. And so that's telling us that we have evidence that our path A is being moderated by our efficacy variable. So basically this first regression is nothing more than a moderated multiple regression. If we scroll down a little bit further, you'll see that I've got simple slopes and tests of those simple slopes that have been generated at 1 standard deviation below the mean, at the mean, and 1 standard deviation above the mean on self-efficacy. So in other words, this dy dx column contains those simple slopes that are given right here. So again, these are the effects of interest on engagement at 3 different levels of our proposed moderator efficacy. So you can see that all 3 of those simple slopes are statistically significant. And one other thing to point out too is that at 1 standard deviation below the mean, it's 0.223. At the mean, it's 0.347, and 1 standard deviation above the mean on efficacy is 0.471 or thereabouts. And so as you can see, the slope appears to be increasing as we move from lower levels of efficacy to higher levels of efficacy. And if we look at the profile plot, that actually gives you a little bit better picture of what's going on. So you can see that our blue line right here is efficacy. This is 1 standard deviation below the mean, so that's the 0.22. The slope for that line is 0.223. At 1 standard deviation above the mean, that's our green line right here, and so you can see that has the most pronounced positive slope. And then obviously the red line right here is associated with being at the mean on our efficacy variable, and you can see that that slope is falling in between those other 2 slopes. So now we'll scroll down a little bit further, and we have our second regression that has been run. So you can see right here that if you recall, our proposed mediator was this engagement variable right here. So you'll see that this is the regression coefficient from the mediator to achievement right here, which is our dependent variable, and you can see that slope is statistically significant. And so we'll scroll down a little bit further, and then we have our output that is used in order to test for moderated mediation, and then also test the conditional indirect effects. So you'll see right here we have the index of moderated mediation that's been generated. So it's 0.00566, and we have a confidence interval, a 95% confidence interval that has been generated. So in order to test the index of moderated mediation, what we're going to do is determine if the null of 0 falls between the lower and the upper bound of that confidence interval, or if it falls outside of that confidence interval. So if the null of 0 falls between the lower and the upper bound, then we would maintain the null hypothesis and assume that we do not have evidence of moderated mediation. But if 0 falls outside the lower and the upper bound, as it appears to be the case right here, then we have evidence of moderated mediation. And so from that, then we can look at the conditional indirect effects that have been generated. These were generated at, again, using one standard deviation below the mean on efficacy, our moderator, at the mean, and one standard deviation above the mean on our moderator. So these are the three conditional indirect effects at those three levels of the proposed moderator. And so we can test each of those as well. And so you can see that 0 does not fall between the lower and the upper bound of the conditional indirect effect at our representative low point on efficacy. It does not fall between the lower and the upper bound at the mean on efficacy, and it does not fall between the lower and the upper bound for the conditional indirect effect at our high point on efficacy. So you can see then that all three of those conditional indirect effects would be deemed as statistically significant. Okay, so now let's make a little change here. So instead of setting centering equal to 0, we'll set it to 1. So we are going to request mean centering of our x and w variables. So now I'll rerun the analysis. And we'll go back to our first regression model. And so as I was mentioning before, these coefficients right here for the two variables that are involved in the formation of the product term, in both of these cases, these variables were mean-centered. That's why there's a little MC at the end of these. And so basically, now we can interpret each slope as a predictive relationship between a given variable and the mediator for a case falling at the mean on the other variable. So in other words, the effect of interest on engagement for cases falling at the mean on efficacy is 0.347, and then the effect of efficacy on engagement for cases falling at the mean on interest is 0.2296. And so there you go. You'll also notice that the slope for the interaction term is exactly the same as before. And when we scroll down, you'll see that we have our simple slopes that are given. And you'll notice one of the things to keep in mind is that at the mean on the centered variable right here, you'll see it says 0.3471208. You'll see that that number is reproduced in our table up here. So that's that number right there. So you can see just by looking at that this number right here is just one of the simple slopes that we computed below. So when we scroll down though, you can see that we have at one standard deviation below the mean, at the mean, and above the mean. And so those numbers are all the same as what we had seen before when we did not use mean centering of those variables. And so all those three effects are exactly the same. We have the same statistical significance for each of those effects as well. As we look at our plot right here, you can see that the scaling's changed a bit, but the actual simple slopes are exactly the same. And then one final demonstration, we're going to change the global conditioning value. So I'll set this equal to 0 right here. We'll leave our centering on, and then we'll execute the selection again. And going back up to our first regression, you'll see that because we still used mean centering, these coefficients and their tests are exactly the same as before. When we scroll down though to the simple slopes and tests, these values right here are going to be a little bit different from what we had seen before. And the reason why is because now we are generating simple slopes at of the effect of our interest variable on engagement at the 16th, 50th, and 84th percentiles of the efficacy variables. So that's why these numbers are going to be a little bit different, but you can still see that they're all positive. They look like they're increasing as we move from lower efficacy to higher efficacy, and you can see that all three of those are statistically significant. When we scroll down a little bit further, you'll see that our results are pretty much the same for that second regression model. But then when we scroll down a little bit further down here and look at our index of moderated mediation and our conditional indirect effects, these values right here that are shown in this column, these numbers well, the index of moderated mediation is going to be exactly the same as before, so that you can see once again that 0 does not fall between the lower and the upper bound. So in other words, we have evidence of moderated mediation taking place. But with respect to the conditional indirect effects at the low, medium, and high points that we've designated for the efficacy variable, just keep in mind that again we've generated these values using the 16th, 50th, and the 84th percentile of the efficacy variable. And so when we're looking at our plot of the simple slopes from the first model, these slopes are generated again at the 16th, the 50th, and the 84th percentiles of the efficacy variable. Okay, so that pretty well wraps up this video presentation. Again, if you look underneath the video description, you'll find a link to the data file, a link to the do file that I've written. You'll also find a link to a supplemental PowerPoint that provides a lot of additional information. So be sure to download that as well. So I appreciate you watching, and you guys have a great day.